All right, we're going to start with the discriminant. Quick show of hands. If you've heard of the quadratic formula before, raise your hand. All right, if you've heard of completing the square before you did the lesson for me, raise your hand. Okay, that's more people than I would have expected, actually. So the discriminant is actually like one piece of the quadratic formula. And we're actually going to talk just about that part first, and then we'll talk about how it works with the rest of the quadratic formula. So the discriminant gets its very own variable. It's capital D. Awkward because it's exactly the same as capital D for domain, but you just kind of have to tell from context. So capital D equals B squared minus 4AC. So this is like one little piece out of the quadratic formula, and we care about it because it tells us some information, which sometimes that's all the information we need. Sometimes we don't actually care what the answers are. We don't care what the actual solutions are. We just want to know if those solutions exist or what kind of solutions exist. And when that's the case, we don't need to do all the work of the whole quadratic formula. We can just do this little chunk of work. It's less tedious and gets us to what we want to know sooner. So basically, the discriminant is kind of like a score. And that score can fall into three different categories. One category is that that score is less than 0. One category is that that score is 0. And the other category is that the score is greater than 0. All right, so if the score is greater than 0, then we are able to conclude that there are two real solutions and that those two solutions are different from each other. Okay, so they're two different numbers that are real numbers. Now, up until this point, all the numbers that you've ever heard of were real numbers. But pretty soon we're going to learn about imaginary numbers, and those are new. So those will also come up in the quadratic formula as well, but we're starting with real numbered solutions. So if you do the discriminant and that score is actually equal to 0, that will tell you. Now, it's a little awkward how your book says this. Your book will say that there's one real solution, but I would like you to add a word to that. I want you to say that there's one unique real solution, because actually there are two, but they just happen to be the same as each other. And I realize that sounds really weird, but if you remember our conversation the other day with completing the square, we talked about perfect square trinomials and how a perfect square trinomial is a binomial squared. So if I have like x plus 2 all squared and I go to solve, I'm going to get x equals negative 2. But I'm getting it from two factors, so it actually like occurs twice. Does it sort of make sense to everybody? It seems a little silly, but there have to be two factors in a quadratic. There can't really just be one. It has to be something times something, so you can get an x squared. It just happens that those two somethings happen to be the same something. So your book is going to call it one real solution for right now, but I'm uncomfortable with that because I know it's coming in Unit 5. And if we let ourselves think of that as really being one solution, Unit 5 gets a little confusing. Okay? So I'd like you to think of it as two solutions that happen to be the same. Good? So we call it one unique solution. All right, now less than 0 is where the interesting stuff comes in. If we're only interested in real solutions, then we would say that there are none. So we're going to write down here 0 real solutions. But pretty soon we're going to care about solutions that aren't real, that are imaginary. And so I'm going to write dot, 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 and I'm going to put 2 imaginary solutions. And I want to clarify the word imaginary. So long ago, someone kind of solidified everybody's understanding of real numbers versus imaginary numbers. And I am certain that that person did not teach high school math, because if they did, they would never have called them imaginary. So in the mind of this person, we had the real numbers, and then the opposite of that would be the imaginary numbers. And they understand that all they mean is it's the other category of numbers. But unfortunately, when you go around calling stuff imaginary and then you talk to 15-year-olds, the 15-year-olds are like, well, if it's imaginary, why do I need to learn about it? Well, because it's not that kind of imaginary. All right? It's not imaginary as in does not really exist. Okay? It really exists. These numbers are real. They're necessary in real life problems. Like they come up a lot in like really fancy levels of chemistry. They come up in anything dealing with electronics. So like electrical engineers actually have to deal with imaginary numbers. So these numbers solve real, actual, tangible problems. So the name imaginary is just a really unfortunate name. Okay, so it's not imaginary like, ooh, princesses and Disney. It's not like that kind of imaginary, okay? All right, so let's start looking at a couple of problems here. In this question, it says, what is the number of real solutions? Notice it doesn't say what are the solutions. We don't care what the solutions are. We're just wondering how many real solutions this problem has. And when you start solving word problems, you'll understand why you might care about something like that and not care about what the actual solutions are. For the moment, you'll just have to trust me that this is a relevant type of question, okay? What is the number of real solutions, but not what are the real solutions? You're not going to use the quadratic formula. You're not going to try to factor or complete the square. You're just going to use the discriminant. But there's something that's true about both using the discriminant and the quadratic formula, which is that your equation has to equal 0 before you can try to use it. Does our equation equal 0 right now? No. So how should we rewrite our equation? Yeah, so we've got to start by subtracting 49 from each side so that our equation is set equal to 0. Then we can actually start solving the problem. Okay, so now I'm going to say D equals. All right, this A, B, and C are the very same A, B, and C we've been talking about all along when we've used standard form. Okay, so what's B squared for this problem? Yeah, B squared. 196. All right, because 14 squared is 196. And then it's minus 4 times A times C. So minus 4 times negative 1 times negative 49. Now that's 3 negatives. So we are, in fact, going to subtract, right? What number are we going to subtract? 196 minus how much? 196. Oh, so what's our discriminant? 0. So we would conclude, looking up at our little chart above, that there is one unique real solution. In other words, that thing's a perfect square trinomial. Everybody okay? Yes? All right. Next, number 2. So before I do number 2, I'm going to tell you a little story. I'm not going to put it in the recording, partly just because it takes a long time. So I'm going to stop my recording. So taking a look at problem number 2, it says a rocket is launched from the ground with an initial vertical velocity of 150 feet per second. The function h equals negative 16 t squared plus 150 t models the height in feet of the rocket at time in t seconds. Will the rocket reach a height of 300 feet? Okay, not when, but will it happen at all? Does that make sense to everybody, that distinction? It's not saying how long will it take before the rocket's at this height, because that would necessitate an actual solution. We would have to know a t value. This just says, will it ever get that high? Does that make sense? So when the question isn't when will, the question is just, I don't know, will it happen? That's just a discriminant problem. It's less work. Everybody good so far? All right. But we need to incorporate this 300 feet, right? It's saying, will it ever get to a height of 300 feet? Where does 300 go in the problem? Sarah? Yeah, it's the h, right? We're saying, does this thing ever equal 300? So we first rewrite it like this. And then we go, well, the question is just, will it happen? In other words, is there a real numbered solution? Okay? So we can just use the discriminant. But I can't use the discriminant yet, because what do I need to do? Yeah, the 300's on the wrong side. So I've got to subtract 300 from each side so that my equation will be set equal to 0, because none of the formulas work out unless the equation is already set equal to 0. Okay, so now I do the discriminant. I say the discriminant equals, and I'm just going to write it out, 150 squared minus 4 times negative 16 times negative 300. I'm not going to try to do that any of that in my head because I know I'm going to pick up a calculator for this problem. So I'm just going to write it down with the substitutions as is. And then I'm going to grab my calculator and I'll let the calculator do all the fancy arithmetic because this class is called algebra, not arithmetic. So we let the calculator do the arithmetic. Tell me what we get. All right, Katie, what did you get? 3,300. All right, is that a real number? Well, actually, take that back. Is that positive? Is that 0? Or is that negative? Positive, right? This is greater than 0. So if the discriminant is greater than 0, there are 2 real solutions. So that actually means that this rocket hits that height twice, right? Once on the way up, once on the way down. So yes, the rocket will hit 300 feet twice. Are we good?
Is it showing the work explaining it?
Yes. Okay. It's kind of this part, right? Saying that the discriminant is greater than 0, that's how we're concluding that there are 2 real solutions. If there are 2 real solutions, then it does in fact happen in reality 2 times. Are we good? Yes? Yes. All right, next, quadratic formula. Okay, this is the whole kit and caboodle. Now, when you already know the discriminant, there's a short way of writing the quadratic formula, which is x equals the opposite of b plus or minus the square root of the discriminant divided by 2a. Most people memorize the quadratic formula just full on, which is x equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. That's great. I will tell you I actually prefer this method because I like people to be in the habit of calculating the discriminant first and then plugging it in, both because sometimes that's the only work they need to do. And by being in the habit of calculating it first, sometimes they realize they don't need to go any further. But also because I find people have a tendency not to remember that that whole b squared minus 4ac goes underneath the radical. And if you only put part of it under the radical, you get the wrong answer. So by calculating it first and then putting that number under the radical, we avoid that issue. Does that make sense? So my suggestion would be to kind of learn the simpler version and be in habit of calculating the discriminant first. So that's what I'm going to model for you in problem number 3. Everybody good? Yeah? Yes. All right. It says, what are the solutions? Use the quadratic formula. And we have this equation, 5x squared minus 2x equals 2. And right away you should be like, wait, it's not ready. Yeah, I have to subtract 2 from each side because unless this thing has 0 on one side, it's not eligible for the quadratic formula. So we got to make that happen first. Then we can start plugging into the quadratic formula. Now, look at your formula. What is the first thing in your formula? X, absolutely. The quadratic formula starts with x. It does not start with negative b. A lot of students develop the lazy habit of just writing negative b, blah, 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 and they leave off the x. And then after doing that infinitely many times, they've forgotten what it is that they are finding. And when we start using this to solve word problems, they're like, I don't know, I did the quadratic formula, but I don't know what that is. We don't really want to be in that situation. So it just isn't that hard to write x equals before you start doing the arithmetic. And this would be another healthy habit to be in. Start by writing x equals. Don't start with negative b. Does that make sense to everybody? Yeah? All right. So we're going to say x equals. It's going to be the opposite of b, which is how much? 2 plus or minus the square root of. And we're like, oh, wait, we didn't calculate the discriminant yet. Let's do that. So the discriminant is b squared minus 4ac. Now, these numbers are pretty small. We could probably pull this off just doing it in our head. What's b squared? 4, right? Because negative 2 times negative 2 is positive 4. Negative 4 times a times c. How much is that? 40. And that's a positive 40, right? So the discriminant itself is 4. What do we already know about the solutions? There are 2 of them, and they're real numbers. All right, so now we can take that 44 and plug it underneath the radical. And then we know that that is going to be divided by 2 times a. What's 2 times a? 10. All right, now you are going to resist the urge to cross out the 2 and the 10. How come I cannot reduce the 2 and the 10 at the moment, Will? Because there's plus or minus something else. And that something else is completely underneath a radical, and I can't reduce it yet. But what if I could reduce that radical, like simplify the radical a little bit? How does that radical simplify? Yeah, that's 2 root 11, right? Because that's the square root of 4 times the square root of 11. We can take the square root of 4. That's 2. So it's 2 root 11. Now there are 3 terms, each of which is an even term. So now I can go in and reduce. But I cannot reduce until all 3 terms are ready to do it. And if I never reach the point where all 3 terms can be reduced, then I can't reduce at all. Not unless I break it into 2 separate fractions. So let's look at our answer. I am perfectly fine with your answer looking like this, 1 plus or minus root 11 over 5, as long as you understand that that is 2 answers. Your book won't give the answers that way. Your book is likely to write them this way, x equals 1/5 plus root 11 over 5, comma, 1/5 minus root 11 over 5, to emphasize the fact that those are 2 solutions and that each solution is either a sum or a difference. Okay? So I don't care which version of the answer you give, the more concise version on the left or the book format on the right, as long as you understand that those are the same thing, right? The little box on the left and the big box on the right are actually the same answer. Are we good? Yeah? All right. I'm going to stop the video here because it's getting really long, and then I'm going to start another video for the back of the page.